back to my channel. In this lecture, we are going to learn about cache and how to implement that in Spring Boot application. Here we will learn about in-memory cache and why we need it and how we can utilize it. First of all, cache is used to make the performance of the API better. Also, we can say to make the API more available. So how cache works? So imagine you have an API that will retrieve a list of branches every time from a database. So whenever, let's say we have a mobile application. Here we go. This is a big mobile application. Here we go. This is our mobile application. So every time it's calling our branches API for any reason. Okay. So suppose we are a big store, and we have a mobile application. And in our mobile application, there's a button where it can show you all the branches that is available for in a country. So if you think about it, the branches data, it's not frequently changed. So suppose I'm a store, I have 10 branches across the country. I'm not going to open a new branch within a day. So usually it's a process. It's a process that takes time. So the branches data is usually static. So this is one of the use cases where we can use cache. So every time the mobile application is calling the API without cache, the Spring Boot application will go and hit the database, get the list, go back again, and go back. So this without a cache, this is taking more time, because every single hit will go to the database. The trigger from the application to the database, this takes time. Also, the response between the application and the mobile application. So also this is consuming. This is also suppose we are having our database hosted on AWS RDS database. So this is expensive also. It's every single hit is a cost for me, and also for my application. It's more traffic. So how to use cache to make this better? So how cache work? Let's get the cache logo here. For example, this one. Let's call it our cache. So how cache works? Now, when we implement cache in Spring Boot application, or actually in any application, at the end it's an approach. So how cache will work? The first hit will be for getting the branches. After Spring Boot application go and get the list of branches from the database, Spring Boot application will go and store the response in the database. In the cache. Okay. Now, in the next call to this branch, Spring Boot application will check is there data. If there is data in the cache, it will not go to the database. It will take it from here. It will take it. See, I'm not the best one to draw. Okay, so this is the response that will come from the cache. Okay. Now, every time the API will get a request, it will go and take it from the in-memory cache instead of the database. This will make the response time super fast, will reduce it, and also the traffic will be less on the database. So hey, here you are going to gain better user experience because the response is coming so fast, and you are not triggering the database again. Also, it shouldn't be just a database, it can be an API or a microservice. Like it's not Amazon Gateway. Here, let's just do it in a rectangle. Let's see it's their party API. And suppose you are getting that list or any data that is doesn't change frequently from a third party API. So you can use cache in the same approach to store the response that is coming from a microservice from a third party or even from an internal microservice. So this is the overview of how cache works. Now let's get into our example and implement that in Spring Boot. Now in Spring Boot application I have already made an application without configuring any cache in it. This application is for just creating a user into the database, deleting a user, retrieving the user details, and updating the user. Now let's run this application. Now in this application I am connecting to a local database, so it's not H2 database, so it's a Postgres database that I have implemented in the last video. Okay, in this database I have a user. Okay, so let's call this API to get the user ID, user by ID. So every time I'm hitting this API, the API of get user is getting the user from the database by invoking the user repository. So as you can see, every time here I'm logging the user, so every time it's calling the database to retrieve that user. This is the norm. So what we can do, we need to implement cache because I don't want to retrieve the user details every time from the database. I want it to be stored in the in-memory cache. To do that, first thing we need to enable the caching in our application. To do that, let's create a class called app_config, and we will annotate this as a configuration bean. And in order to enable the caching on the application level, all we need to do is just use the annotation enable caching. By this, we are telling Spring Boot to enable the caching on this application. Now, we are not done yet. Now, in the demo controller, this is the API that gets the user details by ID. So I want this API to get the user details from cache. So we go to the user service where we are doing our logic to retrieve these details, and all we need to do is using the annotation cacheable. So we are letting Spring Boot know that this method here will be cached, and we need to define two values for the caching. First of all, we need to tell Spring Boot the name of the cache. What I mean by that, if we go back to the draw.io, in cache it will store it will store like this. It will store, like for example, in your application you have more than one thing that you need to cache. You have user details, you have branches, you have car list, whatever the caching is. We need to tell Spring Boot that the name of the cache. For example, we have a cache for users and we have a cache for branches. So Spring Boot will, by defining this, will understand that okay, any uh, any response related to the users, I need to store it under the user's caching, under the user's cache by specific ID D12, and we have stored another user details and so on. So here in the application, we need, since we are getting the user details, we need to tell Spring Boot that this will be stored under the user's cache, and we need to define the key. Oh, sorry. We need to define the key because when you are storing a response, okay, you need to tell the cacheable the which primary key or unique ID that the cache needs to consider in order to store this data in the cache, because you don't want duplicates, and also this caching data needs to be managed correctly. So in our example, we are using the ID, of course, as a primary key in the database for the user. So we can also rely on that to be used in the memory cache for storing. So in order to define the cache, we need to follow this syntax using the hash and providing the name, which is the ID. By this, the first request will come to get this get user by ID. The cacheable annotation will tell Spring Boot to check, do I have data in this user's cache for this ID? If no, it will skip the in-memory cache and go and get it from the database. After retrieving that data from the database, it will store the ID and the data related to it in the cache. So next time, it will take it from the cache. So here, let's fix this to say retrieving from database. And let's run the application again. Okay, let's try it. Let me just close this Docker engine, don't want it. Let's go to Postman. I have this user already exists in our database. So let me call it. The first call is retrieved from the database because I just ran the application. So in-memory cache doesn't have anything. Now, if I call it again, see, the response timeout has been improved. This is the first thing. The second thing, I didn't call the database, so this line wasn't executed. These lines in the function wasn't executed because the cacheable found a data for this ID 354 in the memory cache, so it took it from there. So okay, this is the first annotation for storing the data in the in-memory cache. Now suppose we need to update a user email. Okay, we have a function, our mobile application, to update the user email. So usually it's fine, we retrieving the user, updating the email, and saving that user in the database again. But suppose we have updated the email for this user. This user, if we updated the email, it will be updated in the database. But in the cache, it will stay retrieving as this2 at Gmail. Why? Because the cacheable will the cacheable is annotated for this function here, and it doesn't know or have any control about this function, and in case we did an update in the database, it will never know. So in order to consider this into the caching, we need to use this annotation called cache put. This annotation will tell Spring Boot that when you update the user email, go and update it in the cache in case it exists. So if you updated the email, okay, this is fine. You need to go and check if in the cache, in memory cache, if there is an ID exists, you need to update the email for that one as well. So the in memory cache data can be synced with the data that exists in the database. In order to implement that, we need to use the cache bot and also use the same value. We need to tell Spring Boot, for this action you need to update the user's cache, and you need to consider the key ID as the unique key. So now here I have made the bot API to do the update. So I'm using query parameter. This is not correct, but this is what I made. Usually it should be in the body. Anyhow, this is not our concern. Now we will update this. Let's just rerun the application first. Now when we call this API, it will go to the database, and for the user 354, it will update the email to test3@gmail.com. And in our cache, it's test2. So if we didn't implement the bot cache, it will update in the database, but not in the memory. But now it will update in both cases. So let's update it. So as you can see, the email has been updated for the user. Now, if we called it again, if we called that again, see if it's updated, and it's retrieving that from the cache. By this, we have implemented how we can update details in the database and sync it also in our memory. This is a very important concept actually, because if you didn't that, or if we don't have this option available, every time we do an update on the database, our data in the memory, it will be not updated, so our data will be wrong. So this is a very important annotation to consider. Now, the last thing that we need to learn about is similar to the update, but suppose I have deleted a user from the database. It will not be reflected on the cache memory by itself, of course. So we need to consider that. We need to tell Spring Boot that whenever we delete an application, you need to go and delete it from the cache. For that, we use the annotation called cache evict. For this one, we just need to tell Spring Boot the same for the users, for the cache users. You need to delete any data that has this ID. Oh, sorry, that has this key. So let's run it again. Now here we are retrieving this user from the database. From the cache. So let's go and delete it. Okay, the user has been deleted. Let's go back and check. See, I'm getting internal server error because it couldn't find the ID in the cache, and because we didn't handle the exception of no such element exception, so we got no value present. So the user was deleted from the database and also from the cache. So this is everything about in-memory cache. It's straightforward, very useful. In this lecture we have covered the in-memory cache. In the next one, we will learn about the distributed cache and how to cache the data in external entities like Redis, and how to install Redis using Docker, and how to modify our application property and which dependency do we need to go there. So see you in the next lecture. Thank you.